Okay, so we have already discussed factoring out a greatest common factor, and that is still the first thing you always look for in every problem to see if you have a greatest common factor. And then number two, of course, with four more terms, we've done grouping now for a couple of days. So today we're going to probably have the shortest lesson, talk about maybe the easiest type of factoring. And the reason it's easy is because we've already really talked about binomial squares, perfect square trinomials, conjugates, and the difference of two squares. And we talked about them in that order when we were multiplying. Well, now we are going to recognize the perfect square trinomial and factor into binomial squared. And then we'll, if you remember, we abbreviated this one. We'll recognize dots, the difference of two squares, and then know that that gives us conjugates, okay? So we've already talked about these. Now we're going to talk about being able to recognize them, because if you're able just to recognize them, like you were saying earlier, most of this stuff will be done in your head, okay? So you'll recognize it, and then you'll either factor into a binomial squared or into conjugates. All right, this is a binomial squared. As a review, multiply. Multiply that binomial squared out. Now, the common mistake that people make is square the 2x and square the 3 and they'll be left with binomial. When you multiply binomials, what method do you use?
Foil.
Good. And so when something is squared, that means that you multiply it by itself. And so do that using the FOIL method. First, outer, inner, last. And what happens most of the time with outer and inner, do you remember what you get? Like terms, right?
Wait, what order did you go?
First, outer, inner, last. Now this answer is called a perfect square trinomial. And when we were multiplying at the first part of the chapter, this is the kind of problem that we did. We had a binomial squared, we had a perfect square trinomial. Alright, so in today's lesson we're going to go backwards, okay? So how do you recognize a perfect square trinomial? Where there are three tests. The first term is a positive perfect square. The last term is a positive perfect square. First two tests are really easy because if one of them's negative or one of them's not a perfect square, you can say, no, it's not a perfect square trinomial. All right, test 3. trying to be just very specific so that you'll have something to go by. It's another reason we're recording this lesson today so that you can go back and look at it. But step 3, take what you would square to get the first term and the last term. Multiply them together and then double what you have. The answer should be the middle term, and ignore the sign of the middle coefficient, because positive or negative is not going to matter as far as if it is a perfect square trinomial or not. Okay. So if I look back at my problem, 4x squared minus 12x plus 9, is this a positive perfect square? Yes, positive. 4 is 2 squared. X squared is a perfect square. 9 is a positive perfect square. Okay, those two are easy. All right, what would you square to get 4x squared? I just told you, 2x. What would you square to get 9? All right, multiply them together and then double it. Do you get this? 4 times 3 is 12, right? And it doesn't matter whether this is positive or negative. You can say, oh yes, that's a perfect square trinomial for sure. Okay? So we started out with a binomial square. We know we were going to get a perfect square trinomial. But remember, for the end of this chapter, we're going to have the perfect square trinomial as our problem and factor it into a binomial square. Now that was a lot to write, wasn't it? All of that you do in your head. No work to show. And once you're able to recognize that you have a perfect square trinomial, then factoring it's easy. You're just going to write the binomial squared, and we'll talk about how to do that. Is this a perfect square trinomial? Let's go through the 3 tests. Is this a positive perfect square? Yes. Is this a positive perfect square? Yes. What would you square to get this? What would you square to get this? If I multiplied those together and then said times 2, would I get this?
Yes.
Okay. So here's a binomial squared. What do you square to get this? What do you square to get this? And just drop them in the sign. That's it. You did all of it in your head. You determine if that's a perfect square trinomial. Once you do, you say, what do you square to get the first term? What do you square to get the last term? And drop the middle sign, binomial squared.
So that's all you do.
That's it.
Oh, that's easy.
Better than grouping.
Oh yeah.
Well, some of you I know love grouping and graphing. All right, is this a positive is this a perfect square trinomial?
Mm-mm.
Any even power, 2, 4, 6, 8, 10, 12, those are perfect squares. Whoops. So is 49 a perfect square? Yes. 7 times 7, right? Is y to the 4th a perfect square? What would you square to get y to the 4th? Y squared, okay. Is 1 a perfect square? 1's a perfect everything, right? It's
What,
perfect
like-
cube, perfect square.
A perfect square is like sometimes itself.
Something you multiply times itself to get that number, yeah, right. All right, what would you square to get this again? 7y squared. What would you square to get this? 1. If you found their product and times it by 2, would I get the middle? Yes, so I did all that in my head, and then I said, okay, drop the middle sign between them, binomial squared. So you guys who like to work in your head, this is for you. Whatever the middle sign is what you use here. Now, when I was determining if this is a perfect square trinomial, regardless of the sign, that's how you find the coefficient in the term here. But you use the middle sign when you're factoring. That's true every time. All right. Is this a perfect square trinomial?
Yes.
What do you square to get this? X. What do you square to get this? 4. What's their product? Times 2. 8. Okay. Now what if it's not a perfect square trinomial? That's what we learn tomorrow. Okay. So far, everything's nice. Wonderful. Alright, perfect square trinomial?
Yes.
What?
No.
No.
Is 3 a perfect square?
No.
No.
Alright, now what's the first rule of factoring? Greatest common factor. I really should look at that first. Is there a greatest common factor? Like 3? 3 won't go into 16 one. And so we'll have to save this one for another day because it's not a perfect square trinomial. That one is, if it will factor with trial or error bottoms up, we'll do it that way. If not, we'll call it prime and use the quadratic formula. Okay, so for right now, let's just say it's not a perfect square trinomial. First of all, because of that 3. All right, is this a perfect square trinomial? Pass all 3 tests. Y'all are forgetting the last test. What do you square to get this? What do you square to get this? What's their product times 2?
Oh, not
6. So be really careful. You got to do all. I know it's easy to do the first 2 tests, right? And you say, yeah, sure. But you got to do the middle also. So this is not a perfect square trinomial. That one is not factorable. We would call it prime. It wouldn't even factor with trial and error. We would have to use the quadratic formula to solve that, which we will learn soon. Is this a perfect square trinomial? What's
Yes.
staring right at you to tell you no? What? This negative right here? No. Well, I would, but it's on the video, okay? So, we would do trial and error. We would try trial and error. It would not work. So we would call this one prime, and again, we'll go to the quadratic formula. When you say something's prime, it's not like no solution, okay? That just means you can't do this method. All right, can you do these 2, please? You ready? What would you square to get this? Anybody know?
8 squared.
8. A squared, yes. What would you square to get this? B. Their product times 2, would it be 16 A squared B? Yes. Drop my little sign, square it.
What do you mean their product would be?
Oh, like when I multiply these 2 together, find their product, and then times it by 2 or double it, I would get this. All right, these are called conjugates. How did we define conjugates before?
Same term, a different middle signs.
Same term, different middle sign. What did you get when you fold them out? What's going to happen with outer and inner? First, outer, inner, last. What will happen with outer and inner?
They cancel out.
Cancel out. So I'm left with the difference of 2 squares. How do I recognize that? Perfect square, difference of 2 squares. I mean, it's exactly what it says it is, okay? So if this is a plus sign, it's the sum of 2 squares, right? I'm talking about the difference of 2 squares, and we'll give you conjugates. If these aren't perfect squares, how could it be the difference of 2 squares? It can't be. So that's really all you're looking for. Do I have a difference, and are those perfect squares? Those are the tests for that. Is that the difference of 2 squares?
Yes.
It tells you it is, doesn't it? Bless you. So this is the difference. This is perfect square. This is a perfect square. So here's all you do to factor them. You write down your conjugates. Does it matter which one comes first, plus or minus? It does not. Okay. What would you square to get this? X. What would you square to get this? You're finished. See why I call this the easiest lesson of all of them? So if that was a plus sign between the a squared and 25, that would be the sum of two squares, and we would know. We wouldn't even have to think because we know it's prime. Is this the difference of two squares? 16 is a perfect square, x squared is a perfect square, 49 is a perfect square. Is there a greatest common factor that I could factor out? No. Alright, so I would have conjugates. This is dots. I'm gonna get conjugates. What goes here? What do I square to get 16x squared? 4x. Good. What do I square to get 49? It doesn't matter whether the plus or minus came first either, okay? Does this have a greatest common factor? No. Is it the difference of two squares? What do I say? Now, if it had a greatest common factor, you wouldn't call it prime. Okay, you actually factor out that part, but. Does this have a greatest common factor?
Yes.
Of what?
3.
3. So let's factor it out. I would be left with 3x squared plus 5. Now, is this inside here the difference of two squares so I can keep going, or am I finished? Is that the difference
No.
of two squares? No. So I'm finished. If it were the difference of two squares, I would factor it again. So now we're getting into, it is possible to factor the same problem using 2 or 3 of these different things we've learned. You might do greatest common factor of the difference of two squares. You might do a greatest common factor in a perfect square trinomial. Which one always comes first?
Greatest common.
Is there a greatest common factor?
No.
No, there's not. 7 will go into 49, but it won't go into 36. Is this the difference of perfect square, perfect square, perfect square, perfect square?
Yeah.
Absolutely. And so I'll have conjugates. I keep writing my plus first. It doesn't matter. Alright, can somebody tell me what goes here?
6
6 times 6 is 36. 8 times 8 is a squared. And here
7
7b. These special cases we're talking about today are pretty easy. Okay, on page 455, we're doing 19 to 37, the odd, for tomorrow. Write the problem, give the answer. You know how long this is going to take you? Not very. Not very, because these were all short.